All right, good afternoon. Welcome back to Trigonometry. So today in this video, we're going to be talking about something called fundamental trigonometric identities. You already know some because as we were going through the definition of the trigonometric ratios, you learned that sine was equal to 1 over cosecant because that was reciprocal of sine, and secant was equal to 1 over the cosine of theta, and then the tangent was equal to 1 over cotangent of theta. These are called reciprocal identities. Okay, so that's what these are called. There we go. Nobody is going to care too much that you know the actual names of these things until you get to until you get to a couple of chapters in, where we have to prove some of these identities, and the book will ask you, like, which one did you use? You have to know, I'll use this one. Now, on a pencil and paper exam, or anytime after you've finished that section, nobody will ever ask you for the name of that identity ever. Okay, so that's not a thing you have to commit to memory. The other one, remember that tangent of theta was equal to sine theta over cosine of theta, and that cotangent is equal to cosine of theta over the sine of theta. These are both called your quotient identities. Okay, and again, nobody will ever care if you know the names of these things past the section where they will actually ask you to know the name of it. But in real life, like, you don't have to carry these around. You don't have to memorize these. Even in the textbook, when they expect you to do it, it's a drop-down menu where you get to pick which one you want. So you have to recognize them more than recall them. So the kind of test you're studying for is like a multiple choice test, and it's not even a test, it's on homework. Okay. We take our tests in the testing center with paper and pencil. I will not ask you to, like, write down your six reciprocal. I will not ask you this. So if you don't remember the names, it's not going to be a problem. The names of the next three are called Pythagorean identities, and we're going to go ahead and show you what that is. So if I go back to my Pythagorean theorem, right, we have a triangle. We have our adjacent side, we have our opposite side, right, for any particular angle, and we have our hypotenuse. So what I'm going to do is I'm going to say we have adjacent, the side, the adjacent squared, plus the opposite side squared is equal to the hypotenuse squared, right? Just Pythagorean's theorem. But now what I'm going to do is I'm going to divide everybody by hypotenuse. I'm going to multiply both sides of my equation by 1 over hypotenuse squared. Okay, assuming we have a right triangle, this can't be 0, right? So we're not divided by 0 here. We just divide by hypotenuse squared. So what I have here is adjacent over the hypotenuse squared plus opposite over the hypotenuse squared is equal to hypotenuse over hypotenuse squared. Now, we're going to go ahead and simplify this down. This is just going to be 1, okay? Now, do you have a trigonometric ratio that looks or sounds like adjacent side over hypotenuse? Like, you sure do. That's the cosine of an angle. So that's cosine squared plus opposite over hypotenuse. That's sine squared. Okay. Usually, because 2 plus 3 is the same as 3 plus 2, we usually write this as sine squared plus cosine squared is equal to 1. This is your Pythagorean identity. This is something that once you've learned it, this may never leave your head ever again. Okay, this is one of those things that it's going to come up over and over and over and over again. Okay, from now until when you finish taking any math class or any engineering class, it's going to show up over and over and over again. So it's a thing you have to memorize. Um, when you take calculus, okay, they're going to put in sine of some horrible, the fourth root of e to the x plus 1, divided by the natural log of a sine of theta, right, squared, plus cosine squared of some horrible fourth root of e to the x plus 1, divided by the natural log of cosine squared. And then they're going to say, I'd like you to do calculus on that sum. And what the calculus teacher is actually asking, every calculus teacher in existence has done this, is they want you to recognize this is sine squared of a thing plus cosine squared of a thing, and that equals 1. And we want you to do calculus on the number 1. We don't want you to do calculus on this horrible thing that we concocted. We want you to recognize it and say, oh, that's 1. And then that's a much easier problem. Do calculus on 1 rather than whatever nightmare I dragged this out of. Okay, they don't want you to do that. Okay, some students do, and they like get to the end, they're like, I can't believe you wasted 40 minutes, 50 minutes working through all of this stuff when you just had to do with one. Okay, so it's a thing you have to remember for the rest of your life. That's your first Pythagorean identity. There's two more. Now, truth be told, I never memorize these because I always derive them, and that's how I get them. So I've got sine squared plus cosine squared is equal to 1. And what I'm going to do is I'm going to divide everybody by cosine squared. Right? We're just going to divide the whole equation piece by cosine squared. I'm just multiplying 1 over cosine squared by everything. Sine over cosine, you remember what that is. That's tangent. So that's tangent squared. Cosine over cosine, I hope that's 1, right? And then that is equal to 1 over cosine. That's secant squared. Okay, so that's, and you could rearrange these. Okay, we could do something like 1 is equal to secant squared minus tangent squared. Okay, and again, same trick I just pulled up here. We have secant of some horrible thing I pulled out of a nightmare minus tangent squared of some horrible thing I pulled out of a nightmare. What we want you to do is recognize that's 1 and do calculus on that 1. We don't want you to do the calculus on the horrible things that I extracted from my nightmare here. We're going to do the same thing, except instead of, well, we divided by cosine, how about we divide by sine? So I'm going to take my sine squared plus cosine squared is equal to 1, and we're going to multiply by 1 over sine squared on both sides. Okay, everything's going to get multiplied by 1 over sine squared. That's sine squared over sine squared. Okay, plus cosine squared over sine squared is equal to 1 over sine squared. Okay, now sine squared over sine squared, that better be 1. Cosine over sine, remember that's cotangent squared. We're using our quotient identity there, just to bring that back, is equal to 1 over sine. That's a reciprocal identity. That's cosecant squared. Okay, so your three Pythagorean identities, and it would typically be told to you like this, and people will refer to them like this. Okay, sine squared plus cosine squared is equal to 1. Let's say we have tangent squared plus 1 is equal to secant squared. And then, of course, we have 1 plus cotangent squared is equal to cosecant squared. Okay, and they'll generally refer to this. You have to memorize these. Technically, I've only memorized the first one because it's so easy for me to get to the other two. But if you are worried that maybe you'll forget in a panic on an exam, memorize all three of these or practice deriving the other two enough times so that I can't shake this out of you if you get scared. Okay, just you will always know it will never be a problem. Okay, we use these things for a lot of different parts, but right now we are still in the evaluating things right now. Later on in the class, we will just be working with identities. But for now, we're going to use these identities in order to figure out what's going to happen. Now, I'm going to go back to the unit circle for just a moment. Okay. So again, pretend this is round. Now, in my quadrant 1, right, if I pick any point on my unit circle, we're going to get a plus x value. We're going to get a positive y value. Okay, we are in my quadrant here, we are positive x's, we are positive y's. So quadrant 1, all of my trigonometric ratios are going to be positive. Okay, in quadrant, so let's go look at quadrant 2. Okay, so in quadrant 2, okay, that's going to be over here somewhere. It's going to be a negative x value, but a positive y value. Okay, remember, x's go with my cosine, y's go with my sine. Only the sine is positive in quadrant 2. So only the sine should be positive in quadrant 2. Okay, if I look at quadrant 3, I'm going to have negative x values, right? We're going to be over here somewhere, we have negative x values and negative y values. We're under the axis. So if I take negative over negative, right, the x over y or y over x, tangent is going to be positive in the third quadrant. Okay, we go over to the fourth quadrant. Okay, so we can go ahead and look at that fourth quadrant. We're going to be down here somewhere. My x's, we're going to have positive x values, but we're going to be below the axis, negative y values. So positive x values is going to tell me that we have cosine is going to be positive. So that gives us a little mnemonic that we're going to go deal with, right? So we're going to say ASTC. Okay, this is the first initial of the trigonometric ratio and its reciprocal that are going to be positive. So all of them are positive. Only the sine and the cosecant is positive. The tangent and cotangent are positive, and then the cosine and secant are positive. So we always just say all students take calculus. Okay, and that tells you which trigonometric ratio is going to be positive in which quadrant. Okay, and that's an important thing that we're going to be working with in just a little bit, because the homework is going to expect you to, like, they're going to give you an answer, they're going to give you a number. They're going to say, hey, the sine of this theta is equal to the square root of 7 over 4. Okay, and they're going to say, by the way, theta is in quadrant 2. Could we figure out what the cosine is? Like, what's the cosine of this angle? Well, here's what we're going to do is we're going to say that we have sine squared theta plus cosine squared theta is equal to 1. Let's go ahead and plug some stuff in. So we have the square root of 7 over 4 squared, because the sine is square root of 7 over 4, plus I don't know what cosine squared is. That's what they gave us the job to figure out. So we're going to say that. Now, let's go ahead and square this. So we have square root of 7 times the square root of 7 is going to be 7. 4 times 4 is going to give us 16, plus I don't know what cosine squared is yet, is equal to 1. Solving for this, we have cosine squared is equal to 1 minus 7 over 16, right? So we could say that cosine squared, right, is going to be 16 minus 7 all over 16. We're just going to multiply this by 1, 16 over 16. So, okay, 16 minus 7, that's going to give us 9/16. And that's equal to cosine squared. Okay, so we have cosine squared theta is equal to 9/16. Well, I didn't want cosine squared, I wanted cosine. How's that going to work? We're going to take the square root of both sides. When you take the square root of something with a variable in it, it's saying what values are going to lead into this. So we're going to need a plus or a minus. We have cosine is equal to plus or minus. Can I take the square root of 9 and call that a 3? Can I take the square root of 16 and call that a 4? And say that this is going to be plus or minus 3/4. Okay, is it plus or minus? Well, which quadrant is it in? I know that theta is in quadrant 2. Cosine there, remember, all students take calculus. Sine is positive in quadrant 2, but cosine should be negative in quadrant 2. So my cosine of this angle is going to be negative 3/4. Okay, and that's how you're going to solve some of these problems. There's a lot of different ways to skin a cat here. You could do this a number of different ways where we said sine is equal to the square root of, sine is equal to the square root of 7 over 4. We put it in quadrant 2, right? Right, here's my angle. Here's my reference angle. So we have the square root of 7 over 4. Could we manipulate this triangle and figure out what is my adjacent side to get my cosine? We sure could. We're not going to do that because they wanted us to solve it in this particular way, because that's why they showed us what the identities were before they showed us what the problems were. So they want us to figure it out this way. But if you got stuck, you're like, I don't remember. There's a lot of different ways around this in order to get to an answer. So let's see, I have a couple more problems here. So doing this, how about we say that the cosine is equal to the square root of 5. So we have cosine of theta is equal to the square root of 5 over 3. All right, and we'll say theta in quadrant 4. Okay, and they want us to find what's the sine of this angle. Okay, so same idea. So you're going to say sine squared plus cosine squared is equal to 1. We have sine squared plus cosine squared. That's the square root of 5 over 3 squared is equal to 1. Let's go ahead and solve this. So we have sine squared theta is equal to, hey, we got to square the square root of 5 over 3. That's going to be, oh, that's going to, we have sine squared plus. Let's go ahead and deal with this. That's going to be 5 over 3 squared is going to be 9 is equal to 1. Let's go ahead and subtract from both sides. We have sine squared is equal to 1 or 9/9 minus 5 over 9. And we end up with 4 over 9. Okay, so sine squared was equal to 4 over 9. Sine must be the square root plus or minus the square root of 4/9. I think I could safely say that the square root of 4 is going to be 2, the square root of 9 is going to be 3, and I have to choose plus or minus. Where did they tell us it was? It's in quadrant 4. Go back, remember, all students take calculus. Okay, so we're going to go back to this. Okay, hey, the cosine is positive here. The sine must be negative. We're going to say that sine of theta is equal to negative 2/3, and that's going to be our answer here. Okay, let's see if we can't do another one or two of these things. Let's see here. We have, um, okay, so let's see. I have tangent is equal to, I have tangent of theta is equal to negative square roots of 3. And then I have that theta is in quadrant 4. So we do that. And they'd like us to find what secant is. Okay, and again, there's multiple ways to do this. So if we go back to our Pythagorean identities, we go back and we say, okay, does anything relate tangent and secant together? Like, oh, look at that. We have tangent squared plus 1 is equal to secant squared. Let's write that down. So we have tangent squared plus 1 is equal to secant squared, and we'll go ahead and deal with that. So tangent squared plus 1 is equal to secant squared. Oh, we're already finding secant. So we can go ahead and do that. So we have negative square root of 3, and we're going to square it. Plus 1 is equal to secant squared. Okay, so we have 3, because square root of 3 times square root of 3 is going to be 3. Don't forget the negative times negative turns into a positive. So we have square root of 3 plus 1 is equal to secant squared. Oh, 4 is equal to secant squared. They didn't want secant squared, they wanted secant. Secant is equal to plus or minus the square root of 4 or plus or minus 2. Well, which quadrant are we in? We're in quadrant 4. We want the positive value. So we're going to say secant of this angle is 2, and that's what they wanted us to find. Okay, so that's how we are using our fundamental trigonometric identities, or yeah, fundamental trigonometric identities in order to figure out like what is going on with this and how are we figuring some stuff out. Okay, so let's see here what I have. Okay, this one is a little bit tricky. So we have the cosecant. And again, there's a lot of different ways of doing this. Cosecant of theta was equal to, I'm going to say this is 7 over the square root of 13. Okay. I'm going to double check that. That seems a little fishy. So maybe I'm not right on this one. So we're going to say 7 divided by the square root. Dang it. 13. Take the square root. And we're going to say 1 over. And then say times 7. Okay, so that's okay. This is a value that works. Okay, we're going to be able to go ahead and say this. So one of the things that we're going to deal with is sine and cosine of angles is equal to opposite over my hypotenuse, adjacent over hypotenuse. If you go back to right triangles, just remember the hypotenuse always has to be the longest side. So we're going to have opposite over something that's longer, adjacent over something that's longer. Sine and cosine are all going to have, a range, as a function. The range of sine and cosine has to be between -1 and +1. Okay, so that has to be in there. So 1 over that, right? Secant cosecant, they have to be either bigger than 1 or smaller than -1. So that's one of those other things that we're going to get to, but it's a thing that you want to check out just to double check it. So let's see here. We have cosecant, and what did they want me to do? They wanted me to figure out what the cosine was. Find cosine. Well, the first thing I'm going to look at is say, well, I don't really have, you know, I have secants and tangents as my Pythagorean identities. We have cosecants and cotangents, but we don't have anything that relates cosecants and cosines. So we're kind of stuck as far as this goes. Tell you what, why don't we start using a couple of different things? We're going to say that cosecant is equal to 7 over the square root of 13. That means that sine is 1 over cosecant, right? It's 1 over cosecant. So it means it's 1 divided by 7 over the square root of 13. So it's really the sine is square root of 13 over 7. Now we can go back and say we have sine squared plus cosine squared is equal to 1, and we can go ahead and get our cosine squared. Okay, again, we could have just drawn the triangle, right? From this point, if we draw our triangle, we say, okay, we're going to draw a triangle and say this is square root of 13 with 7. Could we figure out what this adjacent side and hence what the cosine is going to be? Like, you better believe we can. And that's entirely allowed. But, in this section, they want us to solve the problem a certain way. I can't look over your shoulder and tell you didn't solve it right because there's a lot of different ways. And when you get to calculus, we don't tell you, well, rarely do we tell you, you must solve this problem in this particular way. We just don't do that. We leave it up to you. You figure out how you want to solve it. So in this case, we're trying to practice our Pythagorean identities. So we've got our sine squared plus cosine squared is equal to 1. We're going to say square root of 13 over 7 squared plus cosine squared is equal to 1. We're going to say that's going to be 13. 7 times 7 is 49. Okay, now it's going to be tough. Plus cosine squared is equal to 1. So we're going to say cosine squared is equal to 1. Well, we're going to say this, 1 minus 13 over 49. I'm going to say, how about we do 49 minus 13 and everybody's over 49. So that way I could figure out what's going to happen there. So we have 49 minus 13. I end up with a 5, no, that's a 6. 4 minus 1 is going to be 3. That's going to be a nice number. So we actually end up with sine squared is equal to 36 over 49. Of course, I got this out of a textbook. Can't you tell? Because the numbers came out to be nice. That's how you can tell it came out of a textbook. Okay. So what did they tell me about this? They told me that, did they tell me anything about the thing? Trying to find where I got the problem. They said it's in quadrant 2. Okay, so we have, oh no, they didn't. They didn't mean, oh yes, they did. They meant quadrant 2. Yeah. So cosine is going to be negative. Okay. So when I go ahead and say my cosine rather, right? That's what we calculated. Be better with our cosine squared. Don't let me lie to you. So we have our cosine squared is equal to 36 over 49. So cosine is equal to the square root plus or minus 36 over 49. And since I'm in quadrant 2, we're going to say that it's going to be negative. Cosine of theta equals negative. Square root of 36 is 6. Square root of 49 is 7. So we're going to get negative 6/7. Okay, so that's another kind of a problem. I think you probably have enough to do these problems on your own. You have to memorize your reciprocal identities. So you have to memorize these. You have to know your quotient identities. That's tangent is equal to sine over cosine. Cotangent is equal to cosine over sine. Okay, so that's quotient. Okay, and you have to have your Pythagorean identities. At least that sine squared plus cosine squared is equal to 1. Okay, the other ones you could derive and get that, but just as a way to remember it, okay, I would write this down for my homework because we always want to make sure we're writing sine squared of theta or sine squared of something plus cosine squared of something is equal to 1. I don't want to write Sign with as just SIN, that's an archery term. It needs to fall short. This is why the religious folks took it, because it's a fall short. But we don't want to just take SIN. We don't want to take just COS. Okay. We want to have an argument attached to each and every one of these things. So make sure you're practicing that. But if you're writing down for scrap paper, like, oh, I have to figure out what this is, and then we're just going to divide everybody by sine squared, then we're just doing scrap work over here. I'm just writing this out. You don't have to be quite so formal if it's just going to be off on the side for scrap. But the moment I introduce this into a problem, you put the argument back in there. Okay, so I hope that helps a little bit. But that's our fundamental identities and how do you solve problems using those. There's other ways to do them, so you take your pick which way you like. And I'll leave you with that, and I'll say thank you very much for watching the video, and we'll see you next time.